Okay, so this week, the first part is on modifying the GUI in a more advanced way. So last week we covered the start working on the GUI, like how to hook up callback functions. And this week we are actually going to modify the window layout main.ui file. And we are modifying this file using the glade. It's a GUI editor tool, and you can use it by calling this command. So inside glade, you can then rename components, move positions of each component, and add new components like text boxes, like switches, and things like that. Now I'll move on to the glade demo. So this is the same directory as where we ended last time for tutorial 6B. Let me go to the code. And I'm going to use the last draw map pinkify switch with text. And this is associated with our modified GUI. I'm just making sure that we are using the right one. And then we can start up glade using the command that it just showed you, which is this one. Glade libstreetmap resources main.ui. And you will see this when you open up glade. So this is the main.ui that we are currently using. And inside the main.ui, can open up the main window. Here is the main window. It's the entire thing. And inside the main window, you have the outer grid, which is a 3x3 row and column grid containing everything inside the main window. You have the inner grid, which is a smaller grid that has all of the buttons. And you'll see that the rows is 7. So 3 and 4. 7 rows, and columns are 3. 3 columns. And inside the packing, you'll see the left attachment. That is the coordinate in terms of the outer grid. So you are 1 from the left. 0, this 0, 1, 2. And you're 0 from the top. Then this area is the main canvas area where you're drawing your canvas on. And these IDs are the strings in the code that we are referring to. So if you want to draw on the main canvas area, you will set main canvas as the identifier, and this should be the same string as the ID that we're setting in the glade. This is the same as this ID. If your program can't find the same ID, it will set fault. Okay, and at the bottom, there's a status bar, which is where we display status. Like this is where we display your messages when you call the print message command. top levels, containers, control, display. When you click on that, they will show you all of the widgets that you can use in your UI. And this is the documentation of everything. Shows the documentation. And when you are clicking on the status bar and click on documentation, it will show you the documentation for status bar. Besides that, this is a preview button that you can see how your map looks like right now. So right now, if I just not modify anything and I just go run the mapper, it will look like this, which is similar to the preview. And next, let me make sure that I'm covering everything before going to the next thing. Yeah, that will be one thing that I will be showing you. Yeah, okay. So the first thing I'll be showing you is how to change the title of your program, like this. It is defaulted to EasyGL application example, and we want everyone to change this to the name of their map. So I will go to the main window. And inside general, you will see the title here. To modify this, you will need to ensure that this is not checked. And I will just give the title EC297 demo. And you will need to set it to your map's name. Okay, and after I did this, I click save here. It will save to the main.ui file. So now if I use git status here, it will show me that main.ui has changed. Main.ui. Yeah, when you click save. And when you preview, it will look like this. So it changes the title. And when I run the code here, so when you change the main.ui, you don't need to recompile anymore. You can just rerun it and it will show up here. Because you didn't change the code, it's just reading from the main.ui file. Okay, the next thing I want to show you how to move different components around. Like if I want to move the toolbars to the left and the canvas to the right, I'll go into packing and I'll change the left attachment, which is the coordinate system with respect to the outer grid. I'll change this to 0, and I'll click on main canvas and change this to 1. Save. And if I run the code, buttons are on the left. I'll change it back.
Like it doesn't show up when
The third one is just a random one that's not showing.
it's empty.
I won't show it. It has to be an empty one at the right and at the bottom. Okay.
Oh, it's fine.
Yeah. You can change it by removing it and you can see what happens. I don't know what will happen. Okay. Next thing. I want to add a new button to, not a new button. I want to add a text box to the end of the buttons. Now. So the first thing, I will change the rows count to 8 so that it has an extra row at the bottom. And then I'll go to control and I'll add a new GTK entry for a text box. I'll click on here. And this will create a text box for me. And I want to extend it to the second grid, which I can do by setting the width to 2. It won't let you because it will extend to the next one unless you change the left attachment to 0. But in this case, I want to also add a label to the left. So I also want to add a text label to the left. Yeah. Adding a label here with some text. So the text can be set here. I'm not changing the label right now, but you can change it to whatever you want. And don't forget to give an ID to both of them. So for the label, my text label. Yeah, you have to refer to the code and using the ID. And for the text box, I'm giving it entry. I'm just making sure I'm using the right things because I have the code ready. But you can give it to whatever you want. So then how you would use this in your code? Because if you have this, you save it. And if you don't change anything in your code, it will just be a text box that does nothing. And when you preview, it will be a text box that does nothing. But you can enter things into it, but your program won't recognize anything. So to find out how to do it, click on this. You can also either use this read documentation button, which will open up the documentation directly, or you can also right click on text entry and go to read documentation. It will open up the same window. So let's go to the description, and the description will give you a detailed description on what this is. It is a single line text entry widget. And if the entered text is longer than the allocation of the widget will scroll so that the cursor position is visible. You can use it for passwords by setting the visibility. You can use it to display invisible characters, also for passwords, and you can also have the caps lock warning turned on or off. So these are just very useful things that you may need for using GTK entry. And what we will be needing is to get the text from the GTK entry. Yeah. So in your program, you have to explicitly call the functions listed here. So you can set the icon. You can set the icon for a search bar, for example. And in this tutorial, I'm just going to show you how to use get text, which is this one. In the documentation, you can click on it and see how it's used. So it returns a character pointer, which is essentially a string that's in the buffer of the text box, and given the GTK entry, which is the text box. So it retrieves the contents of the entry widget, and there's another equivalent thing to do, and it gets it when you call this function. Yeah.
Then how would I know what has text been entered into the wait?
You have to write that. So the documentation will give you the parameters and the returns. Go back. GTK entry, and if you scroll down, these are the functions, these are the properties, style, signals, types, and values. And the object hierarchy will tell you how this object is inherited from its parents. So remember in ECE244, if you are inheriting something from its parents, it can use everything defined in its parents, and it has 2 children. If you want to use specific things in the children, you may need to use the children, like the child type instead of the GTK entry. And there may be more useful things in there. You can explore it by reading through the documentation. And now I will, let's save. With this, I will run mapper, and you'll see the text box shows up. And let me go to the go to this one. This is the first one I want to show. Let's read through the code and see what it does. So everything else are the same. You have the main window, main canvas. You have the add canvas, draw main canvas, pinkify, which has the pinkify button from what we had before. I have the initial setup with text entry. And in the text entry, we have the button called pinkify at row 6. This is row 6 in your inner grid. Inside the inner grid, this grid. This is row 0. 1, 2, 3, 4, 5, 6. So this will add a button here. So there are 2 ways to create buttons. One is through Glade, one is in your code, like this. And here it registers a callback function called toggle pink with text, which is defined here. And in here, we are not worrying about the widgets. We are toggling the pinkify button, toggling the pinkify global variable, which will either print draw the map in pink or not. It also gets the object text entry that we just created. That's the GTK entry that we just created for the text box. It gets it. It will cast it to a GTK entry, which is one of its ancestors in the hierarchy. We will call the GTK entry getText function. And this, it just casts it into a GTK entry. Yeah. And this will get the text, put it into the text, and we will do update message, which will display a message in the status bar. And we will trigger refresh drawing to show. So as I modify the code, I will need to recompile. So what is the expected behavior of this map now? Proceed.
Okay, so when you press the label should also down there, which is how full everything.
Yeah. When you click on pinkify, it will output here. And if I do something else, it won't, except when I click on pinkify. And you can zoom in, pinkify, zoom out. Yeah. That stuff. I'll go to the next part where I'm actually going to add an overlay, which on top of your canvas. I'm just using Switch as an example. You can use other things that you want. So first thing, this is the main canvas. I'll click on it and I'll drag it to another position so that it's out of my way. And now I go to a container and create a GTK overlay, and I will add that here. So now this position has the GTK overlay, which is a container. And an ID, which we should never forget to set, we will be setting canvas overlay. And now I want to add back the main canvas into it. So I will click on main canvas, right click, cut. Go to the overlay, right click, paste. Now the main canvas is inside the main canvas overlay. Then if I want to add something on top of the canvas, I will go to Control. I'm just adding a switch as an example. Switch, click on main canvas overlay. Here. And I will add widget here. So now there will be a switch here. And if you preview, it will look like this. There will be a switch at the main canvas area. This shouldn't have any performance impact because this is just UI. Like, unless you add more code. Because you have to add more code with it.
Because I remember Professor Bentley was saying that something with transparency, right? If you change the transparency, it's more fast. Because then the transparency has to allow these calculations. Rather than if like something's okay. I was wondering if having it all
You can time it. I don't have the right answer right now, but if it's always there, it's not like computing anything, that it shouldn't add up anything. But if you have to add something in the code to hook up to this, then there may be some. Okay, I will then save this and run mapper. So you will see that there is a switch added on top of your main canvas. And in this case, you won't be able to drag and zoom the main canvas. Here, you have to use the buttons because the switch is on top. Now I'll go to the code and I'll comment out the last thing, which is new. So this is after adding the switch. We have the same things here. And we have a new initial setup function here. So in this one, we have a pink switch instead of the pinkify button. We have the pink switch and it gets the object pink switch from the UI, which means that I'll need to set the ID of the GTK switch to pink switch. And then we use this pink switch and we call a G signal connect, which will connect the signal to the switch. And it will, like, these are just things that you should be able to get from the documentations. And this sets the callback function to be pinkify switch. So the function is here. This is also something you can find from the documentation. So this function has a fixed return of a G Boolean, which is a Boolean, but associated with the GTK library. The Pinkify switch, this passes in the pink switch as GTK switch, but we are not using it in the code, so we are commenting it out. There's the switch state, which tells you if the switch is on or off, and the application. So in this case, we are setting the Pinkify to the switch state. So we're not toggling it anymore using a button. We're just using the switch to control the Pinkify. And we are forcing redraw every time. And return false. And from the comment, it says returning false means GTK's usual callback is now called to visually update the switch. Where? This is telling the GTK library. It's not related to you. It's telling the library that a callback is called and it will visually update the switch. You can read it and see. The documentation should be detailed enough to answer a lot of your questions. And go up. Connect our text entry area to callback when the user hits enter. So this is how your program will know when the user hits enter. So it will also get the object using getObject and ID. Use gsignal connect text entry, which is this object, to be activated. And it registers the callback function text entry enter. And let's see what that callback function is. So now this is the same things that we did before for the button. So this will be called every time the user hits enter. And it will get the text from the text entry widget and it will update message. Let me save it, and this one should be saved. Make mapper. So now what should this do? Yes. Mhm. You are able to, but you just need to find out how. I'm not showing you how. The documentation is your friend. And yeah, that's the first part. glade and GTK entry. And yeah, this is just, I just showed toggling pink. The packing tab is used to adjust position, and you can make it more detailed, like how you would. Yeah. And you can add more containers, like containers can contain other widgets. So that's usually how you can modify things. And yeah, that's the first part. Do you want to take a rest or? Yeah, we can take a 10-minute rest or 5 minutes, up to you. Okay, so the next part is on timing and profiling. So I will be covering a bunch of tools that you can use for profiling your program to see where time goes. So currently, we are expecting you to know the big O analysis so that you know how fast an algorithm can compute. Like O(n) square function will theoretically take longer than O(n) log n for larger n's. And your C++ STL library, it provides complexity for most of its algos, like its structures. Like a map is a binary search tree, so it's O log n. And the hash, which is the order map, is O1.
It's in the documentation.
Yes, it's in the documentation. You can also guess based on your ECE244 knowledge. For example, if you are calling a function by value, it's probably calling the copy constructor, which will be slower than just passing by reference. So if you are passing like a large array or a large vector, then that's probably calling the copy constructor. And you may want to call that pass by reference instead. Guessing based on what you think you know is bad, but everyone will do it. And using the stopwatch, for example, when you want to time a function, you can print out a statement at the beginning, print out at the end, and you can use a stopwatch to time between like the print statements. So timing should be measured because if you cannot measure it, you cannot improve it. And we want you to improve the portion of your program that takes the longest time. That's the most efficient way to do it. How to measure the actual performance? The first way is to write code to measure time using the chrono library, as you just said. You can, this has the lowest overhead, but it can measure parts of a function, but it may have some shortcomings because if you don't write it, you won't know. You can sample using a debugger. Inside the debugger, you use pause and continue. And the most time, if you are stopping in the function for the most of the times, then maybe that function is taking up the most time. You can use a profiling tool to do everything for it. So you don't have to add anything in your code, just profile it. But it will have overheads because the profiler will interrupt the program at some sampling rate to sample like where time usually goes. It's like sampling using the debugger, but at a much higher rate by the machine. It works well for identifying bottlenecks, but it will take more time and it will take more disk space. It will take more time. to wait for the program to run. I'll show you. It will take more time for you to wait for it to finish.
Oh.
Yeah. I'll show you. For the first method, I think you should already know. You'll get the timestamp before and after the region of interest. You subtract them and save or output the time in the desired format or units, usually in seconds or milliseconds. So for example, if we want to time this function, you will be getting the timestamp before using chrono high resolution clock, get timestamp after using the same function call, and you can subtract them and cast them into something like seconds. And then you can print out or record the time. You can also save the result into a file. So this is example code on how to save into a file. We're using a CSV file that is separated by commas. So every time when you are inside this function, at the beginning, you will get the start time using the chrono high resolution clock. And then at the end, you call profile CSV the start time and the function name. Then inside this function, this helper function, it will get the end time, do the subtraction, and it will output into a CSV file with the function name and the time with an end line. So this will flush the output to the file immediately using std end line. And this will generate a table like this that you can open in your spreadsheet app. And you will see that line just generated at the end. This is a tutorial. So one thing to note is that in this case, you will need to have the CSV file open from the beginning of your program execution and close it at the end, so that it's open the entire time and you will see that lines will be added to it. Now I'll show you a demo on this. By comparison,
That is like,
let me show you a profile on the golden solution that we have. This is slow to compile. The head TAs will do that. Yeah. And labs. Okay. So this code already has the output to file profiling in it. So I'll just run it. I'll do a few zooms and I'll proceed. No. What just happened? Everything froze. So inside here, you'll see a CSV file just appeared called func curve. I'll open that using the Office. This one. And I will import. So you'll see this is load map and draw all features, draw all segments, draw all POIs, and draw. So draw will contain everything before it. So this is the first draw. And you can see the second draw takes significantly less time. And then, yeah. And then the third, the fourth, and if you look at the last draw, it takes more time because it's starting to show the details of the features. And if you compare the times, of these ones, you'll see that like everything after these are really, really small. Draw all features takes the longest time, and draw all segments takes the second. But there may be limitations because you must know what code to measure, because you need to put in the profiler code inside your code. If we can't figure that out, we can use some other tools, like the second one and the third one. So for the second one, we can do it in the debugger, run the debugger, stop it with debug pause, and look at the subroutine and line and the callback to see where you pause. And you can continue the execution. So in the cycle. The more time in the subroutine you stop, the higher probability. The more time spent in the subroutine means a higher probability of stopping there. So if you usually stop in the same routine, you found the problem, and you can just do a profile there. But there may be challenges because sometimes the redraw function is too fast. You can't click on the pause fast enough before it finishes execution. So what to do is to write a loop in your redraw function to redraw many times. So you need to wait for it to redraw many times before it goes to the next function. So then you can be much easier to pause and see where you are. So in your code, we recommend using the profile build, because using the release build, it has the most accurate time estimates, but it's too optimized that many functions are inlined, so you don't know like where exactly they are. But the profile build has like fairly accurate CPU time estimates, and it can pause in any function. Does that make sense? So if the many functions are inline, it might be hidden in the debugger. It's something done by the compiler when it does the optimization in your code. Because the compiler doesn't just like boldly translate your code into machine code. It will optimize by like folding things together. It can reorder things, something like that. But the release mode is the most optimized version of the compile. It will fold many functions so that it's invisible to the debugger. Using the profile build it can pause in any function, and it's not as slow as debug mode. And I will show you how to do that. And I hope VS Code works this time because it doesn't work last time. Of course not. Okay. For the first thing, I will need to set the number of redraws to a higher value. Currently, it's just drawing once. I want to set it to a larger value so I can actually stop in there. I do a 30, and I'll build using profile build. I'll set the target to mapper and launch target to mapper. Primary salesman problem. No,
So loading the map and everything.
but they're tested separately, so it's fine. Yeah, I'm just talking too much. Okay, so I'll zoom in and I'll pause. And let's see the call stack. It's in draw segment, draw line. Continue, pause. It's running now. So the first, sorry. So the first zoom we stopped in draw segments to run it and zoom in. Draw feature. See the draw feature? I'm pausing and I'm looking at the call stack. And we're inside draw feature now. Field poly. Let's do it again. And it's running again. So in the second zoom, we stopped in draw feature. Zoom the third time. And I wasn't fast enough. Not fast enough again. Draw all features. Draw line. Still, yes, this can be annoying to do. See, we are stopping like the third time in the same function draw line. And draw feature. The fourth time. And now we are in, yeah, draw feature. And now we're in draw segment. Draw feature. Draw feature. Draw feature is closed feature. Yeah. I'm looping the redraw for 30 times. Oh, it's the entire draw. Yes. And now we know that we stopped 2 times in draw segment and all the other times are in draw feature. So we know that draw feature is the slowest one. It's features in general. Okay, and let's go into. So that's manual profiling inside the debugger. The last tool that we have is a profiler that does, it essentially does what you just did in the debugger, just at a higher rate. And it will just do everything for you. And then you can just visualize it. Yeah, so you don't have to open up the debugger or anything. It will just run it, do everything for you. So still compile with the profile configuration. Run the exerciser with profile option using this command. And then you can visualize, like after the program finished, you'll have a file called perf.data. And this will store the data that you need to visualize. So you can use this command to visualize it. And still, we want to focus on the redraw function, so we're still setting the redraw number to 30. And when you call that EC297 profile visualize perf.data, you'll see a graph of a lot of functions. So each of these nodes are functions, and edges are how these functions are called. And colors will be the time spent in which function. So these dark blue ones are less time, and these red ones are more time. And these ones are probably calling something here, waiting for something here to finish. If you look at something like this, draw Toronto, draw takes up 74% of total time, but its self time is about zero, which means that about 0% of time is spent in the actual function itself. All of the other times are calling helper functions. And 58.2% of time is calling draw Toronto draw features, and 15.5% is calling draw all segments. This is the get feature type, and This is draw feature. Yeah. Now I'll show that to you. My screen. Okay. So to run the profiler, you have to make sure that you have a lot of disk space because otherwise it will do weird things. No, no. You only have two gigs, so you have to clean up a lot of things.
Wait, how much?
A lot.
More than 2 gigs.
So what I'm going to do is I'm going to make sure that I'm compiling with profile. Make sure by using make clean. It takes time to compile. Yeah, you can double check. Okay, and I'll just run the same command that I just showed, which is this one. EC297 exercise 2 run tester draw Toronto profile. And you also want to make sure that you're not running the program for a long time, because otherwise it will exceed this quota very easily. It takes a long time. Let me see. I'll zoom in until the details are starting to show, which I believe is the next zoom. Yeah. Yeah. That was a very long time. I hope this can work. ECE297 profile visualize first data. And as you can see, loading the file takes a long time. That is what we mean overheads. Yeah, if you can find the problem with Chrono, then that's the best. This is for projects that are large enough that you don't know where time goes and yeah. But sometimes if like Say someone else wrote the code. Yeah, and this is because this quota. So I'll remove that and that. And now I'll run the exercise again, but I'll try to keep the timing small. So it's drawing, not the names and subways. Too many. That was faster, a bit faster.
This type of stuff will be good if you like the.
Yeah.
Why is it only 2 gigs? Is that like a limit for everyone?
That's a limit for everyone, also for me. We have no idea why, but
Someone could change.
happens when people are not coming. So people will think there are no one in the classroom. Okay, yeah, if we are under 60 seconds, this will work. So you'll see that this is when I zoom into it, unknown. Okay. And the next one, signal. So these are the graphical library objects. Let's look at this one. This one is draw Toronto draw all features. We have 37.38%. And draw feature has 30.56% with 2% in its own function. And if we look at its children, let's see, 11.18% is render line, draw line. Yeah. This is this graph. And we can look at it using another graph, which is the flame graph. This takes in the same data file, but just with a different option called flame graph. And this will show you the width proportional to the total time spent in arbitrary order So it's not sequence of events, but these are mostly in time.
So what is the total time span?
So the larger ones will have the more time spent. And if you can double click on draw to zoom in on the sentence. So previously we had this, and if we double click on draw, it will show a more zoomed in view. And I'll go back to my VNC and I'll show you that. Profile visualize -T. Right. Wait.
What are we looking for? Like, if you go back to the presentation, what are we looking for? Going to optimize something.
We are looking for the largest one.
So, with the ECGL, we would be kind of like about ECGL. Drop
Yeah.
feature would be the function like
Yeah. For the EasyGL, the only thing you can do is to eliminate the number you're calling them. But that's usually not possible. So
for the feature.
Yeah.
So that's something we can allow.
yeah. And for the EasyGL draw line with a line width of 0 is a lot faster than another line.
But if it's a line of 0, we don't be able to see.
A line width of 0 is the smallest line width. So you're able to see it. Okay, so it's showed. So this will generate a flame graph.svg that you can visualize inside the browser, like Firefox. So the first part is map and close map. So this is the first draw. These are a few zooms. No, I think this is turning on main and this is turning on subways and a few zooms. If this doesn't come back, then yeah, that's basically the idea. And you can double click on some of those to see. And you should also be able to see that it's still draw feature, which is the one that takes the most problems. And yeah, that's it for today's tutorial. Any questions? Or I guess you asked them.
But I so we have a prototype for WD1.